Northern European ancestry. If your lineage traces back to places like Scandinavia, the UK, Ireland, northern Germany, your ancestors survived long, dark winters with very little sunlight. Lighter skin developed because lighter skin absorbs more sunlight, and sunlight helps your body make vitamin D, which is essential for bone health and immune function. In low sun environments, that adaptation was genius. But here's where the hidden disadvantages start to show up. Fast forward to modern life. That same lighter skin now burns faster and carries a higher risk of melanoma, a serious form of skin cancer. The adaptation that once helped your ancestors survive, cloudy winters now makes intense UV exposure riskier. Then there's autoimmune disease. This is when your immune system, which is supposed to attack viruses and bacteria, accidentally attacks your own body instead. Conditions like multiple sclerosis, type 1 diabetes, and celiac disease appear at higher rates in Northern European populations. Why? One leading idea is called the hygiene hypothesis. Basically, when your immune system evolved in relatively cold, low-pathogen environments, it didn't have to fight off as many infectious threats. In modern, ultra-clean environments, that immune system can become overreactive. Instead of attacking dangerous invaders, it sometimes overreacts to harmless things, or even your own body. There's also hereditary hemochromatosis, a genetic tendency to absorb too much iron from food. In ancient times, iron deficiency was common. Being good at storing iron was helpful. Today, with iron-rich diets, that same trait can lead to organ damage if untreated. And seasonal affective disorder, that heavy, low mood feeling during dark winters, shows up more frequently in populations adapted to extreme seasonal light changes. South Asian ancestry. If your ancestry traces back to India, Pakistan, Bangladesh, Sri Lanka, Nepal, your body may play by different metabolic rules. South Asian populations show significantly higher rates of insulin resistance and type 2 diabetes, often at lower body weights. That means someone can look normal weight by standard BMI charts and still have serious metabolic risk under the hood. Why? Part of it comes down to fat distribution. South Asians are more likely to store fat viscerally, meaning around the organs rather than under the skin. And visceral fat is metabolically active. It pumps out inflammatory chemicals. It disrupts insulin signaling. It increases cardiovascular risk. So, two people with the same BMI, completely different risk profiles. This is sometimes called the thin fat phenotype. You look lean, but internally your metabolism is working overtime. There's also higher prevalence of familial hypercholesterolemia, a genetic tendency toward high LDL cholesterol. Combine that with elevated rates of coronary artery disease, and you get one of the highest cardiovascular risk profiles globally. And here's another curveball: vitamin D deficiency. Darker skin contains more melanin, which protects against UV damage. That's fantastic in sunny climates. But in low sun countries with indoor lifestyles, it can mean reduced vitamin D production, which affects bone health, immune regulation, even mood. Iron deficiency is also more common, particularly among women, due to a combination of dietary patterns and genetic factors. Then there's thalassemia, a blood disorder affecting hemoglobin production, which appears at higher frequencies in certain South Asian populations due to historical malaria exposure patterns. East Asian ancestry. If your ancestry traces back to China, Korea, Japan, parts of Mongolia, there are certain biological disadvantages that show up more often, especially in how your body metabolizes specific substances. Let's start with the most visible one, the alcohol flush reaction. You know when someone takes 2 sips of beer and suddenly looks like they ran a marathon in a sauna? That's often due to a variant in a gene called ALDH2. This gene helps break down acetaldehyde, a toxic byproduct of alcohol. If ALDH2 works less efficiently, acetaldehyde builds up. That causes facial flushing, nausea, and rapid heartbeat. It's not just cosmetic. Acetaldehyde is carcinogenic, meaning long-term heavy drinking with this variant increases risk of esophageal cancer. Now let's zoom out. Lactose intolerance is also more common. Historically, dairy wasn't a staple in many East Asian diets, so the ability to digest lactose into adulthood didn't become widespread. Your ancestors didn't need milk digestion, so the gene didn't stick. There's also higher salt sensitivity. Some populations show stronger blood pressure responses to sodium intake. In traditional contexts with lower processed food consumption, that wasn't a big deal. In a modern high-sodium diet, hypertension risk climbs. As well, bone density trends slightly lower on average in East Asian populations, which can increase osteoporosis risk later in life, especially without adequate calcium and vitamin D intake. Certain cancers, like nasopharyngeal carcinoma and stomach cancer, also appear at elevated rates in some East Asian populations. influenced by genetic susceptibility, plus dietary factors like preserved or salted foods. Southeast Asian ancestry. If your ancestry traces back to countries like Thailand, Vietnam, Indonesia, the Philippines, Malaysia, Cambodia, your genetic history was shaped in tropical, pathogen-rich environments. High heat, high humidity, lots of infectious disease pressure. And when pathogens are common, evolution prioritizes survival traits that help you endure them. One result? Higher prevalence of hemoglobin variants like alpha and beta thalassemia, and hemoglobin E. These are genetic changes that affect red blood cells. Historically, some of these variants provided partial protection against malaria. In modern contexts, though, they can cause anemia or serious blood disorders, especially when inherited from both parents. G6PD deficiency is also more common. That's a genetic trait affecting how red blood cells handle oxidative stress. In certain situations, specific medications, infections, even some foods like fava beans, it can trigger hemolytic anemia, where red blood cells break down too quickly. Then there's metabolic risk. Like South Asian populations, Southeast Asians often develop type 2 diabetes at lower BMI levels. Again, body composition matters more than the number on the scale. Visceral fat and insulin resistance can show up earlier than Western charts would predict. Micronutrient deficiencies, particularly iron and iodine, also appear at higher rates in some regions due to historical dietary patterns. And here's something less talked about: increased vulnerability to certain environmental toxins and infectious diseases. For example, higher hepatitis B carrier rates contribute to elevated liver cancer risk in parts of Southeast Asia. Sub-Saharan African ancestry. If your ancestry traces back to Sub-Saharan Africa, your genetic history is shaped by one of the most biologically demanding environments on Earth. High pathogen exposure, intense sunlight, heat, malaria. And when evolution faces that kind of pressure, it doesn't play small. Let's start with sickle cell. Sickle cell trait, carrying one copy of the sickle cell gene, provided protection against malaria. That's huge. In malaria-heavy regions, that trait increased survival rates dramatically. But inheriting two copies results in sickle cell disease, a serious condition where red blood cells become misshapen and can block blood flow, causing pain and organ damage. It's one of the clearest examples of evolutionary trade-offs. Protection in one context, risk in another. There's also hypertension. Many researchers suggest that salt retention adaptations, useful in hot climates where sodium is lost through sweat, may contribute to higher rates of high blood pressure in modern high-salt diets. Combine that with chronic stress in processed food environments, and cardiovascular risk rises. Vitamin D synthesis can also be affected by melanin levels. Darker skin protects against UV damage, which is extremely useful near the equator. But at higher latitudes with lower sunlight exposure, it can increase risk of vitamin D deficiency without supplementation or sun exposure. Certain kidney diseases, particularly focal segmental glomerulosclerosis, are more common due to variants in the APOL1 gene, another adaptation tied historically to protection against sleeping sickness, a deadly disease transmitted through the painful bite of an infected tsetse fly. Keloid scarring, where scar tissue grows excessively, also appears more frequently. It's not dangerous, but it reflects differences in wound healing biology, and prostate cancer tends to present more aggressively in men of Sub-Saharan African descent, influenced by both genetic and environmental factors. Middle Eastern and North African ancestry. If your ancestry traces back to regions like the Arabian Peninsula, the Levant, North Africa, your lineage evolved in hot, arid climates, with intense sun exposure and long trade route histories. Populations across parts of the Middle East and North Africa show elevated rates of type 2 diabetes and metabolic syndrome. Historically, efficient energy storage was useful in desert environments where food availability fluctuated. But modern calorie-dense diets plus sedentary lifestyles? That same efficiency can turn into insulin resistance surprisingly fast. Then there's familial Mediterranean fever, FMF. This is an inherited inflammatory condition more common in certain groups from this region. It causes recurrent episodes of fever and painful inflammation. It's linked to specific gene variants that likely offered some immune advantages historically, but today can cause chronic health challenges if untreated. G6PD deficiency is also more prevalent in parts of this region, similar to patterns seen in malaria-endemic areas. It affects how red blood cells respond to oxidative stress, and certain medications or foods can trigger complications. Now let's talk about consanguinity, meaning marriage between relatives, such as cousins. In some communities, this has been culturally common for generations. While this strengthens social bonds, genetically it increases the chance that rare recessive disorders appear, because both parents may carry the same variant. Thalassemia variants are also more common across parts of this region, again historically linked to malaria resistance patterns. And here's the environmental mismatch. Heat-adapted physiology may struggle in cold, low-sun, indoor-heavy modern environments, contributing to vitamin D deficiency and metabolic disruption. Your ancestors were optimized for heat, trade routes, and survival in arid landscapes. They were not optimized for office lighting, processed sugar, and heated apartments. Central Asian ancestry. If your ancestry traces back to regions like Kazakhstan, Mongolia, Uzbekistan, Turkmenistan, vast steppe landscapes, brutal winters, nomadic survival, your genetic history was shaped by extremes. And when humans survive in extreme climates with inconsistent food supply, the body learns one trick very well. Don't waste energy. Many Central Asian populations show higher rates of lactose intolerance. Historically, not all groups relied heavily on dairy digestion into adulthood. Yes, some nomadic groups consumed fermented dairy, but genetic lactase persistence varies widely. There's also evidence of thrifty metabolism patterns, meaning efficient fat storage during times of abundance. That's a survival advantage when winters are long and unpredictable, but in modern urban environments with calorie-dense food year-round, that same efficiency can contribute to metabolic syndrome, a cluster of conditions including high blood pressure, insulin resistance, and abdominal fat accumulation. Founder effects, when small, historically isolated populations expand, also increase the frequency of certain inherited metabolic disorders. That's why some Central Asian subgroups show elevated rates of Wilson's disease, a disorder of copper metabolism, congenital hearing variants, and other rare conditions. Stomach cancer rates are also elevated in some populations, influenced by genetic susceptibility combined with historical dietary patterns like preserved or salted foods. Cold-adapted physiology can also mean stronger cardiovascular stress responses, useful in freezing climates, but potentially problematic in environments with chronic modern stress and less physical movement. East African Highlander ancestry. If your ancestry traces back to high-altitude regions of Ethiopia, Eritrea, parts of Kenya, your ancestors lived thousands of years at elevations often above 2,000 meters above sea level. That's thin air, less oxygen, every breath working overtime. High-altitude populations often develop adaptations that improve oxygen delivery. Some groups show differences in hemoglobin regulation, the protein in red blood cells that carries oxygen. Others exhibit elevated red blood cell production. At altitude? That's brilliant. It keeps your tissues supplied despite thinner air. But here's the twist. At lower elevations, especially with sedentary modern lifestyles, elevated red blood cell levels can increase blood viscosity. Thicker blood flows less smoothly. In some cases, this contributes to polycythemia-related complications, like increased clot risk. There are also hemoglobin variants present in some East African highland groups, shaped by historical pathogen exposure. Certain immune profile differences, advantageous in specific infectious environments, may create different susceptibility patterns when exposed to entirely new disease ecosystems. Now layer in modern diet. Populations adapted to traditional highland diets, often lower in processed fats and refined carbohydrates, can experience metabolic strain when exposed to high-fat Western diets. Insulin resistance risk can increase rapidly under dietary shifts. Iron regulation differences also show up in some subgroups, occasionally increasing susceptibility to iron overload conditions. And here's something subtle. Cold intolerance outside temperate highland climates. Bodies tuned to specific altitude and temperature combinations don't always adapt seamlessly to drastically different environments. Indigenous American ancestry. If your ancestry traces back to indigenous peoples of North, Central, or South America, your genetic story includes one of the most dramatic population bottlenecks in human history. Small founding groups crossed into the Americas thousands of years ago. Fewer starting genes means less genetic diversity. And when populations remain relatively isolated for long periods, certain variants become more common. Now enter the thrifty genotype hypothesis. In environments where food supply was unpredictable, feast, famine, migration, seasonal shifts, bodies that stored energy efficiently had a survival advantage. If you could pack on fat quickly during abundance, you survived winter. That's smart biology, until modern processed food arrives and never leaves. Today, Indigenous American populations show some of the highest rates of type 2 diabetes globally, and not just slightly higher, dramatically higher in certain communities. Efficient energy storage plus constant high-calorie intake is a metabolic collision. Gallbladder disease is also more prevalent, linked partly to cholesterol metabolism. Differences. Rheumatic diseases appear at elevated rates in some groups. And due to reduced genetic diversity from historical bottlenecks, certain recessive disorders can appear more frequently within specific tribes or regions. There's also increased susceptibility to alcohol dependence in some populations, influenced by metabolic differences, historical trauma, and social factors interacting with biology. Pacific Islander and Polynesian ancestry. If your ancestry traces back to Polynesia, Samoa, Tonga, Hawaii, or other Pacific islands, your lineage includes some of the most impressive navigators in human history. We're talking about people who crossed thousands of miles of open ocean in canoes, no GPS, no snack bar, just stars, currents, and survival. And survival at sea demands one thing: energy efficiency. Many Pacific Islander populations evolved extraordinarily effective energy storage systems. When you're voyaging across the Pacific with unpredictable food access, the ability to conserve calories and store fat quickly is life-saving. But now place that same metabolism into a modern environment with constant access to ultra-processed, calorie-dense food, plus reduced physical labor. The result? Some of the highest rates of obesity and type 2 diabetes in the world. There's also elevated risk for gout, a painful inflammatory arthritis caused by the accumulation of uric acid, crystals in joints. Efficient protein and purine metabolism that once helped maximize nutrition can, in modern dietary contexts, increase uric acid accumulation. Cardiovascular disease risk also rises significantly when physical activity drops. Historically, daily life was physically demanding: fishing, voyaging, agriculture. Modern sedentary lifestyles create strain on bodies built for movement. Larger average body frames, once advantageous for strength and resilience, now place increased mechanical stress on joints when paired with inactivity and weight gain. And in some communities, rates of rheumatic fever complications and certain cancers are higher due to a combination of genetic susceptibility and environmental factors. Arctic and Inuit ancestry. If your ancestry traces back to Inuit and other Arctic populations, your genetic history was forged in one of the most extreme environments humans have ever lived in. We're talking sub-zero temperatures, months of darkness, very little plant life, almost zero carbohydrates for most of the year. So what did your ancestors eat? Primarily fat and protein from marine mammals and fish. And over thousands of years, the body adapted. Certain Inuit populations carry variants in genes like CPT1A, which affect how fatty acids are metabolized. In simple terms, their bodies became extremely efficient at using fat as fuel. But here's where modern life complicates things. When traditional high-fat, low-carb diets are replaced with refined carbohydrates and processed food, that fat-optimized metabolism can struggle. Rates of metabolic disorders rise sharply under dietary transition. There's also increased risk of vitamin D and calcium imbalance when traditional marine-based diets, naturally rich in vitamin D, are replaced with store-bought alternatives. In environments with minimal sunlight for much of the year, dietary vitamin D was crucial. Pseudocholinesterase deficiency is more common in some Arctic populations, a genetic trait that affects how certain anesthetics are processed. In medical settings, that matters. Higher rates of specific respiratory conditions are also observed, shaped partly by cold climate lung adaptations interacting with modern housing and infection patterns. And in some subgroups, infant mortality from rare metabolic disorders is elevated due to inherited variants that were neutral, or even advantageous, in traditional contexts. And if you want to understand how these biological trade-offs shape your behavior, habits, and even personality in modern life, watch the next video.